Have you ever stood at the beach, felt the spray of a wave hit your lips, and instantly tasted salt? It's such a familiar sensation that we rarely stop to question it. The ocean is salty. It's one of those facts that feels as obvious as the sky being blue. But here's the surprising part. Earth didn't start with salty oceans at all. In fact, if you could travel billions of years back in time and take a sip of seawater, it might not taste anything like what we know today. So how did the oceans become salty, and why did they stay that way? The answer is a slow, planet-sized story involving rain, rocks, rivers, volcanoes, and timescales so massive they're hard to imagine. Let's explore, right here, on History of Simple Things. To understand why the ocean tastes salty, we first need to talk about where salt comes from. The saltiness of the ocean is mainly due to dissolved minerals, especially sodium and chloride, which together form sodium chloride, what we commonly call table salt. But these minerals don't originate in the ocean itself. They come from the land. Rainwater, although it feels clean and fresh, is actually slightly acidic because it absorbs carbon dioxide from the atmosphere. When this rain falls onto the Earth's surface, it slowly breaks down rocks through a process called chemical weathering. Over millions of years, this weathering releases tiny amounts of minerals from rocks, including sodium, calcium, potassium, and magnesium. These minerals are then carried away by streams and rivers, flowing steadily toward the sea. Rivers are one of the most important contributors to ocean salinity. Every river on Earth contains small amounts of dissolved salts picked up as water moves across soil and rock. When rivers reach the ocean, they deliver these dissolved minerals into seawater. Water itself doesn't disappear. It evaporates, forms clouds, and falls again as rain, but the salt stays behind. This means the ocean acts like a giant collection bowl, continuously receiving minerals from rivers while losing fresh water through evaporation. Over hundreds of millions of years, this process has slowly increased the salt content of the oceans, turning them into the vast salty bodies we know today. But rivers aren't the only source of salt. Deep beneath the ocean, along cracks in the Earth's crust called mid-ocean ridges, volcanic activity plays a major role in ocean chemistry. Seawater seeps down into the ocean floor, gets heated by magma, and reacts with hot rocks below the surface. During this process, some minerals are added to the water, while others are removed. This heated, mineral-rich water then rises back into the ocean through hydrothermal vents. These vents may look like strange underwater chimneys, but they're part of a global system that constantly recycles and modifies seawater, helping maintain the ocean's salty balance. You might wonder, if salt is constantly being added to the ocean, why hasn't it become unbearably salty by now? The answer lies in balance. While salt is added through rivers and volcanic activity, it's also removed in several ways. Some marine organisms use dissolved minerals to build shells and skeletons. When these organisms die, their remains sink to the ocean floor and become part of sedimentary rock, locking away salt for millions of years. In other cases, seawater gets trapped in isolated basins where evaporation leaves thick salt deposits behind. These natural processes help prevent the ocean from becoming saltier over time, keeping salinity within a relatively stable range. Another fascinating detail is that the ocean isn't equally salty everywhere. Salinity varies depending on location, climate, and ocean circulation. In hot, dry regions where evaporation is high and rainfall is low, seawater becomes saltier. In contrast, areas near river mouths, heavy rainfall or melting ice tend to have lower salinity. The Dead Sea, for example, is far saltier than the ocean because it has no outlet. Water flows in but only leaves through evaporation, leaving salt behind in extreme concentrations. Earth's oceans, however, are connected by global currents that help mix water and distribute salt more evenly across the planet. So why does the ocean taste salty, but lakes and rivers don't? The key difference is time and scale. Lakes and rivers are constantly refreshed by rainfall and runoff, and they usually have outlets that allow water and dissolved minerals to flow onward. The ocean, on the other hand, has been collecting salt for billions of years. It's the final destination for nearly all surface water on Earth. While fresh water comes and goes, the salt accumulates, giving the ocean its distinctive taste. What's truly remarkable is that the saltiness of the ocean has helped shape life itself. Marine organisms evolved to survive in salty environments, developing specialized cells and organs to manage salt levels. Even human blood has a salt concentration surprisingly similar to seawater, hinting at our deep evolutionary connection to the ocean. In a way, every salty wave carries a chemical memory of Earth's past, a record of ancient rocks, vanished mountains, and countless rainstorms that slowly shaped the planet. So the next time you taste salt on the ocean breeze, remember that you're experiencing the result of billions of years of planetary processes working together. The ocean's saltiness isn't just a simple fact. It's a story written in water, stone, and time, reminding us that even the most familiar sensations can have astonishing origins. The ocean's salty taste is a reminder that Earth's history is written in water, shaped slowly by time, rocks, and rain. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.